All right, so we're going to go ahead and keep moving forward with Unit 4. So now we are going to talk all about function notation. Okay, and this is a pretty short little section, but definitely things we need to be aware of. Okay, so when we look at function notation, basically what that means is we still have just an equation with x's and y's, except we're replacing our y with f of x. That's our notation, okay? And this helps us to see what is input and what is output, okay, versus x's and y's. So here's our example. If we have f of x equals x squared minus 4, okay, this f, it could be an f, a g, a k, basically whatever letters out here, that's just the name of the function. Okay, this does not mean f times x. Okay, this means this is the function f that when you plug in some little input x, this is what it does to it. Okay, so whatever's inside your parentheses, that is your input. Okay, whatever your x is, that's what's going into the function, into the f function. Okay. And then on this side, it tells you what the function's doing. So for this specific f of x function, whatever we plug in as our input, it's going to get squared, and then it's going to have 4 subtracted from it. Okay? So let's go ahead and look at our strategy when we're dealing with functions. Basically, or here, let me go back up here. So basically, there's two things that could come of dealing with functions. Either they're going to tell you what the output equals, okay? So if they tell you, hey, whenever we plug in a certain x value, it equals 5. Okay, so if they tell you what the output is, then you would just replace this whole y side, or this whole f of x side, with whatever the output is. Okay, now if they give you an input, then all you're doing is plugging it in. Okay, so that's our strategy here, is to determine, have we been given an input or have we been given an output? And then we know whether we're setting our function equal to that value or whether we're plugging that value into our function. So here's some examples. It says use the function h of t equals negative t squared minus 2t minus 4 and find the following. So here it says find h of 2. So notice the value that we're given is inside the parentheses. So if it's inside the parentheses, that is our input. So if it's an input, that's what we're plugging into our function. Now this one uses t's instead of x's, and that's okay. So whatever we have inside this parenthesis, that's what we're going to plug in everywhere we see a t in our equation. Okay, so to find h of 2, basically we are plugging a 2 in everywhere we see a t. So this would give us a negative 2 squared minus 2 times 2 minus 4. Okay, so I'm just taking that 2 that's inside the parentheses and plugging it into this function everywhere I see a t. Okay, and then all I have to do is simplify this. So 2 squared is 4, right? And then I have this negative waiting for it outside the parentheses. And then negative 2 times 2 is negative 4. And then I also have this 4 being subtracted at the end. Okay. So then I just start combining. Negative 4 and negative 4 gives me negative 8. And negative 8 minus 4 gives me a negative 12. Okay. So what this tells me is that when I plug 2 into my function, it equals negative 12. Okay. So this was an example where they're giving us an input because it's inside the parentheses. Okay, let's look at another one like that. Same thing here. It says h of negative 2. Negative 2 is inside the parentheses, so if it's inside the parentheses, that's what we're plugging into our variables. Okay, so again, our function says to do the opposite of t squared. So our t in this case is negative 2. So we have the opposite of negative 2 squared minus 2 times our input, so minus 2 times negative 2 minus 4. Okay, now order of operations says that we do exponent before multiplication. So don't do your double negatives here. Okay, that's not correct. We have to do our exponent first. So negative 2 squared gives me a positive 4, and then we have this negative weighting out front for it. Negative 2 times negative 2 is positive 4, and then we have another negative 4 out here. Okay, so here negative 4 plus 4, that just combines to 0, and we're left with just negative 4. So what this tells us is when we plug -2 into our h function, we end up with -4. Okay. All right, so let's look at the other option. The other option is when we're not given an input, when we're actually giving us the function value. Okay, so here it says solve for h of t when it's equal to -4. So notice our number is not inside the parentheses. So if it's not inside the parentheses, we're not plugging it in. What this is saying is we're trying to find t when the function itself, our output value, is -4. So we're just going to take our function and set it equal to -4. So we have -t squared minus 2t minus 4 equals -4. Okay. So I see that I have a t squared, and anytime I have a squared term, that makes me believe I'm going to have to factor, right? So in order to factor, I want everything on one side so that it's in descending order and equal to 0. I want it in standard form, right? So I'm going to move this 4 over. So when I add 4 to both sides, notice what happens is my 4's cancel, right? I get -t squared minus 2t equals 0. And so that's a little bit better, less to deal with, right? When I still have a t squared, so I'm still thinking about factoring, and my first step of factoring always is greatest common factor, right? And I see they both have a t in common, and they're both negative. So I'm going to go ahead and take out a -t, which will leave me with t minus 2. Okay, and I can't go any further from here because my t that's left over in my parentheses is just a t to the first power, and I can't factor if it's just t to the first power. So now that I have it completely factored, I'm going to set each of these factors equal to 0. So -t equals 0 or t minus 2 equals 0. Okay. On the first one, I divide off my -1, which gives me t equals 0. And on the second one, I move my 2 over by adding, which gives me t equals 2. So this means that my function is equal to -4 when t equals 0 and also when t equals 2. Now, if you want to check your answers on these, you can just take these two solutions you got and plug them back into your function. And if when you plug 0, here we'll check 0. If I plug 0 back in here, that term becomes 0. That term becomes 0, and notice I'm just left with a -4. So we know we solved it correctly because we were trying to find the t values that make our function equal -4. Okay, so do you kind of see the difference? You're either going to be given a number to plug in, and the way that you'll know that that's what you're doing is if the number's inside the parentheses, or if the function is equal to a number, then you're just setting your whole function equal to that number and then solving for your variable. Okay, so let's look at another one like this. Here, notice my 19 is not in the parentheses. It's equal to 19. So I'm going to set my function equal to 19. So I have -t squared minus 2t minus 4 equals 19. Okay, and I want to go ahead and combine everything. Now, it really doesn't matter if you move this 19 over here to the left or if you move all of these values to the right. Okay, you'll get the same answer either way. However, I know that when I move this 19 to combine it with that 4, it's not going to go away like it did on this last one, right? So if it's not going to go away, I know I'm going to have 3 terms. And so when I'm factoring with 3 terms, I'm going to do the sum product chart. And remember, we can use the shortcut on the sum product chart if our leading coefficient is a 1. And right now, it's not a 1, it's a -1. So I am actually going to intentionally move all of this stuff over to the right so that that t squared will become a +1 t squared, because then when I factor, I'll be able to use the shortcut. Okay. If you don't notice that when you're working through your homework, it's okay. You'll still get the right answer by moving the 19 to the left. But if you notice that, it might save you just a little bit of time. Okay. So I'm going to go ahead and move my 4. Let's move my 4 first. So I have -t squared minus 2t equals 23. Oh, you know what? This is one that I need to change. Okay, so sorry, typo. Let's go ahead and change on here. Let's make this a -19. It was supposed to be a -19 and I didn't type in the negative. So on your work, make this a -19. Okay, sorry about that. I'll make this better. Equals a negative 19. I typoed, and if we don't change it, it doesn't work out pretty. Okay, so let's recombine then. So negative 19 and positive 4 leaves me with a negative 15. Okay. All right, now I want to go ahead and move my t terms to the other side also so that I can go ahead and factor. So I'm going to go ahead and add t squared and add 2t. So add t squared and add 2t. So I have 0 is equal to t squared plus 2t minus 15. So in other words, I just moved everything over to the right-hand side of this equation. Okay, and now I can go ahead and look at my sum product chart. So my sum is my middle coefficient here, right, which is a 2. And my product is my first coefficient, which is a 1, times my last, which is negative 15. So I need something that I can multiply to get negative 15 that I can combine to get a positive 2, which would be a positive 5 and a negative 3. So positive 5 minus 3, positive 5 times negative 3. And notice it works for both sections of my chart. And I don't have to do replacing the middle term, right? Because my leading coefficient is a 1, so I can use my shortcut. Yay! So I know that this is going to factor into t plus 5 and t minus 3. And now that I have it completely factored, all I do is set each factor equal to 0. So t plus 5 equals 0 and t minus 3 equals 0. When I solve this one by subtracting my 5, I get t equals negative 5. And the second one, I move my 3 over by adding, which gives me t is equal to 3. Okay? Are we kind of okay? So strategy here is determine whether or not you're plugging in a value or whether you're setting your equation equal to a value. Okay? If you're plugging it in, you just plug in and simplify. If you're setting it equal to it, chances are you're going to have to move that number over so that you can combine your terms and be able to factor. Okay? So on the next page, there are 2 for you to try. Okay? So go ahead and pause the video and try those. And then whenever you're ready to check yourself, unpause it and we'll move forward. All right, so on the first one, all we had to do was plug negative 1 in. It's inside the parentheses, so it's an input. So when we plug negative 1 in, we're squaring it, we're multiplying it times 11, and we're adding 31 to it, right? So when we simplify, we get 1 minus 11 plus 31. When we combine those, we end up with 21, okay? On the second one, we have our function is equal to 1. So we go ahead and write out our function, set it equal to 1. Notice here my leading coefficient is already a 1 on this side, so I don't want to move this one over. So I'm just going to move the 1 over to combine it with that 31, which gives me x squared plus 11x plus 30, which then I can use my sum product chart to find my pair. Okay, and I can use the shortcut. Yay! So this one factors into x plus 5 and x plus 6. When I move that 5 over, I get x equals negative 5. When I move my 6 over, I get x equals negative 6. Okay, is everybody kind of okay? Hopefully we're okay on those, not too bad. Either you're plugging in a number or you are setting the function equal to a number, right? Okay, so let's go ahead and move on. I want to look at using a graph to evaluate the function. Okay, so whenever we're looking at a graph, it's kind of the same strategy. Let me move my camera a little bit. Wait for it. Okay, when we're looking at a function from a graph, it's the same idea. Notice here, I still have a number inside the parentheses, so I know that's going to be an input. So I'm basically plugging it in, right? Or I'm setting the function equal to a number. Now here I don't have an equation to plug it into or to set it equal to, so I have to think about what that means in terms of the picture, okay? So it says we're given this function g of x. Okay, so I'm just going to write over here. Remember g of x, function notation, that just represents y. Okay, that's it. So anytime you're not given g of x, but they tell you what y is, basically you're looking for the x value that gives you that y, right? So in other words, if you are given x, right, you would normally plug it in. Basically, if you are given x, then you are looking for this, okay? If you are given an x, you're looking for y. And if you are given what it equals, that means that you are given a y and you are looking for x. So when you look at these with a graph, you're trying to determine, have I been given the x and I'm looking for the y? Or have I been given the y and I'm looking for the x? Okay, so let's look at a couple examples here. So on this first one, it says find g of 4. 4 is inside the parentheses. Remember, inside the parentheses is where our x is. So what we're looking for is what y value do we get when x is 4, right? So here's how I solve it. I just go to where x is 4. Remember, this is our x-axis, and this one is our y-axis, right? So I go to where x equals 4, which is right here, and I'm going to trace it up until I hit my picture. So it hits my picture right at this point. And that point is where I'm going to get my y value from, okay? So when x is 4, the y value from this graph is at 5. So this would just equal 5, okay? So if we're given the x, we look for the y. Same thing here. They give us the number inside the parentheses. That is our x value. So if they are giving us the x, they are wanting us to find y, okay? So I want to go to this x value, which is 1. So when x is 1, that's right here, okay? I'm going to trace it up until I hit my picture, which it hits right here. And I just want to know what is the y value at that point on my graph. So if I look over to the left, that hits at a y value of 2. So this equals 2. Okay, not too bad. Maybe even easier than the equation, right? Just looking at a picture. All right, let's look at the opposite. Notice here, we don't have the x. Okay, this is what we have to find. We're not given the x. What we are given is we are given the y value. So now we're going to do it the opposite way. We're going to go figure out where is y equal to 6 and then find the corresponding x value. Okay, so again, y-axis is the vertical axis. So I want to go to where y is 6. So I'm going to go up the y-axis until I get to 6. Okay, and I'm just going to trace it across until I hit my picture. The only point on this graph where y equals 6 is this point right here. Okay, so at that point, my y value is 6. And what this is asking is what x value does that happen at? So all I have to do is look down and I can see that that happens at x equals 3. Okay, so this happens at x equals 3. Okay, let's look at one more, same idea. Solve g of x equals -3. Notice we're not given our x value, so that's what we have to find. And we are given the y value. So we know that our y is equal to -3. So we're going to go to our y-axis, which is the vertical one, and we're going to go down to -3. And I want to know where on my picture does it have a y value of -3? Well, it has a y value of -3 right here. And then notice if I trace across, it also has a y value of -3 right here. So I need to find the x values at those 2 points. So the x value here, if I trace up, notice is x equals 0. And if I go to this point and trace up, the x value here is at +6. So that means that I get a y value of -3 when x equals 0 or 6. Okay, not too bad. All right, so there are 4 for y'all to try on the next page. I'm going to give you just a minute. Pause the video. Whenever you're done, go ahead and play the video and we can check your answers. All right, so hopefully you did okay. Notice on the first one, we're solving for x. We want to know where do we have a y value of 3. So if I go to my y-axis and find my 3 and trace it across, there's actually 2 points on my graph that hit at y equals 3. And the first one is at x equals 1. The other one is at x equals 5. Okay. Number 2, they're giving us the x value of 3, and we have to find the y value. So if I go over to x equals 3, which is here, drop it down until I hit my graph, notice that point is happening at y equals -1. Okay. Number 3, we're looking for our y value, right? Because our x, which is inside the parentheses, is given. We have x equals 1. So when I go to where x equals 1 and trace it up, notice it hits right here, which is a y value of 3, right? So these are actually kind of being used backwards, right? Here it says when y is 3, x is 1. This is saying when x is 1, y is 3. Okay. And then our last one, sorry, I have like a crazy glare. Our last one is when f of x equals 0. So they're giving us that y value of 0. So when I go to where y equals 0, which is here, and come across, notice I have a 0 at this point on my parabola, and I have a 0 at this point on my parabola. And those two x values are at 2 and 4. So those are my solutions. Okay. All right. So that is the end of this function notation assignment. So you should now be able to complete that in Knewton. Okay. If you have any questions, let me know.